Okay, hello everyone in a new video. So we have reached part 4 of chapter 5, which is the chapter of electric power and energy in the second unit of electricity. Then we have reached exercise number 15, section 23. The aim of this exercise is to determine the maximum voltage Umax that a resistor D of resistance R can withstand. For this, we set up an electric circuit formed of a DC generator of adjustable value. So let's recall that the symbol of this electric component is given by that. A resistor D, a voltmeter V to measure the voltage U across D, and an ammeter A of negligible resistance to measure the current I that traverses D. So now let me start with part 1. The title of this part is given by determination of R. They are telling me draw a diagram that corresponds to the corresponding circuit that consists of the generator G, D, V, and A. So let's start by the generator G of adjustable value connected to the resistor D. So this is the resistor D. Now notice that we have a voltmeter that measures the voltage of D, and we know that a voltmeter is always connected in parallel. So this circuit will be traversed by a current I. Moreover, here they are telling me the ammeter of negligible resistance to measure the current I that traverses D. So let's connect the ammeter in series. Okay, so the ammeter in this case is measuring the current I. The ammeter can be placed here, 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 or even here. So it's not convenient to place the ammeter here because we want the voltmeter to measure the voltage of the electric component D, although the ammeter is of negligible resistance, which means the voltage is 0. Now there is something missing here, which is the COM terminal. They didn't mention anything about the reading of the ammeter and of the voltmeter, so I'll take it by default to be positive, which means connected to the negative pole. This is the negative pole, so this is the first COM terminal and this is the second COM terminal. This is the COM terminal regarding the voltmeter V, and this is the COM terminal regarding the ammeter. Now in 1.2 they are telling me, knowing U and I, give the name of the law that must be applied to deduce R. Always R can be determined using Ohm's law. Now in 1.3 they are telling me, write the relation that expresses this law, and by the relation it means the equation or the expression, which is simply given by U is equal to R multiplied by I. Now in 1.4 they are telling me the characteristic current voltage of D is given by document 1. Then now they mention document 1, we can use it. So give the value of the voltage U across D when it carries I is equal to 50 milliamps. So now what does this document represent? It represents the variation of U as function of I, and this is the curve. So the curve is the path from I to U and from U to I. Whenever we know the value of U, we know the value of I by considering the corresponding point on the curve, then moving to the corresponding axes. So now they are telling me we need to give the value of U when I is equal to 50 milliamps. So let's say graphically. I repeat that the question is we need to give the value of U when the value of the current I is equal to 50 milliamps, and this is given by referring to this curve. So usually for this statement they give it half a mark. Let's say for I is equal to 50 milliamps, we have, so I 50 milliamps corresponds here. So no need to convert it to the SI because simply I is given by in milliamps. It corresponds to this point on the curve having a value of 5, and its unit is given by volts. So U is equal to 5 volts. Now as for part 1.5 they are telling me deduce the value of R, and by deduce it means that we need to use the previous parts. So notice that here in this case R can be determined graphically using the slope method by considering 2 points, but since they told me deduce the value of R can be simply done by applying Ohm's law, since in part 4 we know the value of U and the value of I. So let's say apply Ohm's law to D. And Ohm's law is simply given by U is equal to R times I, which that we have written this expression here, and we are interested in determining the value of R. After we construct the triangle here, because we have multiplied, then U will be at the top, R and I on the bottom. We are interested in determining the value of R, which is given by U divided by I. Now the value of I is equal to 50 milliamperes, and in order to convert from milliamps to amps, we divide by 1000. So 50 divided by 1000, which is equal to 0.05 amperes. Then the value of R in this case is given by 5, because we have 5 volts for 50 milliamps. This is given by 100 ohms. So the value of R is equal to 100 ohms. Now in number 2 they are telling me determination of U max. In 2.1 give the expression of the power P dissipated in D in terms of U and I, and by the expression they mean the relation or the equation, which is simply given by P is equal to U times I. Notice that here determination of U max, this is a title and not a part of the exercise. Now in 2.2 they are telling me show that P can be written in the two forms, P is equal to U square over R and P is equal to Ri square. Let me start by the form which is given by P is equal to U square divided by R. So we need to prove this form starting from the general form, which is P is equal to U times I. Now comparing this form to this form, you notice that R appears, which means that we need to use Ohm's law. So apply, U is equal to R times I, which is given by Ohm's law. Now comparing also both terms, we see that the term I is absent, which means that it must be replaced by U divided by R. So plugging this I here, we get that it's given by U multiplied by U divided by R, which is equal to U times U over R, which is equal to U square over R. Then P in this case is given by U square over R. And now we need to prove that P is equal to Ri square, which is given here. We always start from the general form, which is given by P is equal to U multiplied by I. Comparing both forms, so notice that in this case R appears, which means that we need to apply Ohm's law, which is given by U is equal to Ri, Ohm's law. Now comparing also both terms, you notice that U is absent, which means that this simply must be replaced here, which is given by R multiplied by I, which is equal to Rii, which is equal to Ri square. Then P is equal to Ri square. So now we can use each of the following forms. Okay. Now in 2.3 they are telling me knowing that the maximum power withstand is P max is equal to 1 watts. And recall that previously we have that the value of the resistance is equal to 100 ohms. And we are interested in calculating U max. So knowing P max, knowing R, and knowing U max, we are interested in determining U max. So notice that in this case we have three expressions of power that are given by P is equal to U multiplied by I. P is equal to U square over R and P is equal to Ri square. Which one we should use depends on the given. So we have P max, which is equal to 1 watt. We have R is equal to 100 watts. We have U max to be determined. So in this case, the only formula that relates P, R and U is given by that. For example, if they are asking about I max, then we will use this one. Okay? Or we can, so we will use this one because we know the value of P and R. We are interested in determining I max. So here, since we are interested in determining U max, we will use this one and not that one. Okay? So let's say P is equal to U square divided by R. Here we can use it directly because we have proven it in 2.2. And we are interested in determining U square. Constructing the triangle of this formula, P at the top. Sorry, P at the bottom here because we have divide. U square at the top. R here, and we are interested in determining the value of U square, which is given by P multiplied by R. Now U carry the label max. Therefore, P will carry the label max, so this is equal to 1 multiplied by 100, which is equal to 100 volts. So U square max is equal to 100 volts. Sorry. Here this is not volts. Notice that at this moment we have determined U square max, but we are interested in determining U max. So what's the type of this equation? This is a quadratic equation. So the degree is 2. How do we solve it? Simply we take the square root of both sides. Then U max is equal to square root of 100, which is equal to 10. So because everything previously is expressed in the SI, so the value of U max will be in the SI, which is volts. Then this is it for exercise number 15. So now exercise number 16. They are telling me the electric circuit of document 1. They mentioned document 1. No, we can use it. Notice that till this moment they didn't mention anything about document 2. We are not allowed to use it. A generator G that maintains across its terminal a constant voltage UG is equal to 9 volts. Then the trick in solving such type of exercises is to write the applied voltage traverse current on the electric circuit itself. A resistor D of resistance R1 is equal to 4 ohms. And let me say that this is R1. This is R1. Because D doesn't reflect that this is a resistor. A lamp L carrying the following indications: 6 volts, 3 watts. Notice that I didn't label these indications on the lamp because yet we don't know if the lamp L is functioning normally. And a resistor D. So we don't know the resistance of the resistor D. In number 1, they are telling me what does each of the indications carried by L represent. So let's start by 6 volt. It's the rated voltage. Of the lamp L, under which it functions normally. Whereas the 3 watts is the rated power consumed by L Now in number 2, they are telling me L functions normally. The moment they mention that the lamp is functioning normally, we can say that the voltage across the lamp is given by 6 volt, as well as for the power is given by 3 watts. Okay. Now in 2.1, they are telling me calculate the current I2 carried by L. So there are several ways to determine the value of an electric current. So for example, we can determine using the law of addition of currents, but in this case we don't know the value of I and we don't know the value of I1 simply because we are following a general rule. Whenever we know the value of current, it will be labeled on the electric circuit. For example, we can apply Ohm's law, but simply in this case we cannot apply Ohm's law because we don't know the value of R. related to L, so RL, we don't know the value of RL, okay? But in this case, we are left with the final choice, which is given by the formula which relates voltage and power and current, which is given by P is equal to U multiplied by I. Knowing that in this case, no need to mention any law, and we are interested in determining the value of I, which is given by I is equal to P divided by U. We are interested in determining the current I2, so this is equal to 3 divided by 6, which is equal to 0.5. Because everything is expressed in the SI, so the value of I2 will be in the SI, which is amperes. So I2 is equal to 0.5 amperes. Okay. Now in 2.2 they are telling me what is the value of the voltage UD1 across D1. So here what refers to an explanation and not to calculation. So we just need to mention that D1 and L are in parallel, so they have the same voltage, knowing that L is functioning normally, so it has 6 volts. So let's say, so for example, we can explain that the lamp L is functioning normally and the applied voltage is 6 volt, but here in this case this refers to say that they are just in parallel, so they have the same voltage. So let me say that L of uniqueness of voltages they have the same voltage. So in this case we can say that the voltage UD1 is equal to UL is equal to 6 volts. Between brackets, for example, you can say that UL is equal to 6 volts normal functioning. Okay. So UD1 is equal to 6 volt. Now after we have determined that UD1 is 6 volts, let's place it here on the figure. Now in 2.3 they are telling me deduce the value of the current I1 carried by D1. Notice that we know the resistance of D1, which is given by 4, and now we know the applied voltage. Then we can say apply Ohm's law. Okay, we know the value of the voltage and we know the value of the resistance. I can be determined using Ohm's law, yes. So Ohm's law is given by U is equal to R multiplied by I. We are interested in determining the value of I. So constructing the triangle of this formula, U at the top, R and I at the bottom, we are interested in determining I, which is given by I1 is equal to U of D1 divided by R1, which is equal to 6 divided by 4. So plugging this fraction on the calculator, then the value of I1 is given by 1.5. Since everything is expressed in the SI, so the value of I1 will be in the SI, which is amperes. Then I1 is equal to 1.5 amperes. Now because we have determined the value of I1, let me place it here on the figure. Label it on the figure. Now in 3.1 they are telling me by applying the law of addition of voltages, calculate the value of the voltage UD across D. So let me say apply law of addition of voltages. So on the left we write the voltage of the battery. Here notice that no points are labeled on the electric circuit, so we'll refer to the naming of the electric component. So this is UG. Always on the left we write the voltage of the battery. On the right hand side of this equation we go across different electric components. Now notice that we have D1 and L are in parallel. So in this case we don't write UD1 plus UL. This is completely wrong, Because they are in parallel, then they have the same voltage. Either we write UD1 or UL, but we don't write them both. So let me say that we have UD1 plus UD. So why we don't write them both? We don't write this and this because they are simply in parallel. This is very similar to say that here we have A and B, say for example. We don't write UAB twice, we write it only once. And we are interested in determining the value of UD. So UG is given by 9 and this is equal to 6 plus UD. So what's the type of this equation? This is a linear equation and one unknown. The unknown is UD. How do we solve it? We put UD on one side and all the other numbers on the other side. So this is given by 3 volts. And we label it here. Now in 3.2 they are telling me the characteristic current voltage curve of D is that of document 2. So they mentioned document 2, now we can use it. So this characteristic current voltage curve correspond to which electric component? To the battery, D1, or to the lamp, or D? They are telling me to D. So this is for D. More than that, they are telling me here UD, which is the voltage across D. They are telling me determine graphically, so let me write down directly graphically. The value of the current I through D, so we must use the graph. How do we determine the value of I? Using the graph first, we need to know the value of UD, and the path will be along the curve. So the passage from UD to I will be the curve. But first, in order to determine I, we need to determine U. Notice that previously we have determined U, which is given by 3 volts. So for UD is equal to 3 volts, which is determined part 3.1. We have that the value of I, this corresponds to this point on the curve, having a value of I is equal to 3 amperes. So I is equal to 3 amperes. And now because we have determined the value of D, the current, so we can label it here, so which is given by 3 amperes. Now in part 4 they are telling me by comparing I, so I which is determined in 3.2 which is given by 3 amperes, and the sum which is I1 plus I2. So we need to compare I and I1 plus I2. First let's calculate I1 plus I2, which is equal to the value of I1 is equal to 1.5. So sorry, this is given by 2 amperes. So notice that the value of the current here is 2 amperes. So now before we compare I and I1 plus I2, we need to determine the value of I1 plus I2. The value of I1 is given by 1.5. The value of I2 is given by 0.5. So this is equal to 2 because I1 and I2 are expressed in amperes. So I1 plus I2 is equal to 2 amperes. Now we are ready to compare I, which is given by 2 amperes, and I1 plus I2, which is equal to 2 amperes. And by compare, we need to say whether one is greater, less, or equal to the other. And in this case, simply I is equal to I1 plus I2. So in this case, we need to tell what law of electricity is thus verified. So notice that I1 and I2 at this point join back to give me the current I, or we can say that I at this point splits into two currents, I1 and I2. And in this case, thus the law of addition of currents is verified. So that's it for me in this video, guys. See you soon in a new one.